appreciate the opportunity to present today to you guys and on proper installation and maintenance of air treatment. So I am the Western Regional Manager for ZEKS. I've been in this role for 4.5 years now, but have about 25 years overall in the compressed air world, as they say. I think first thing we need to just want to move. I don't know why it was wanting to move. Safety, you know, we work with compressed air in piping and vessels and tanks at point of use. So just be careful. You usually will see some of these type of signs on pieces of equipment, may start at any time, high pressure, high noise area, all that sort of stuff. So just want y'all to be safe out there. I'll take this as my safety moment. Don't be opening any valves you don't know what are. So what kind of pressure may be behind those. So just kind of to start off, you know, let's talk about what air treatment is. Air treatment is basically the process of dehumidifying compressed air and filtering it so that the customer can use it for their point of use, whatever they're making, the widget or however they're using air to convey or whatever that may be. And if you don't take care of your air treatment or put in the appropriate air treatment for your application, you could have a lot of different problems happening, spoilage and wearing and tearing of equipment. We get a lot of calls on, hey, my impact wrench only lasts 6 months between rebuilds. How can I make it last longer? Well, what kind of filtering do you have? What kind of air treatment do you have? We can start kind of asking some of those questions and figure out, hey, how about we do this or this or this? And you won't have that downtime on cylinders and rams and conveyor belts and things like that and tools. But also paint jobs, depending on what's getting through the airlines. If it's oil, you could be getting fish eyes. If it's water, you could be getting some crazing happening and so forth. So there's a lot of direct correlation to what kind of air treatment people have. So we want to make sure that we put in the appropriate, and we only dry the air to your application. On a previous webinar, I kind of went through that, the selection source of what type of air treatment is appropriate for what types of applications. So please refer back to that. It was a couple months ago. But just again, kind of to reiterate, what are we talking about? So when we compress that air, we take that 7 gulps of air and compress it down into 1 gulp. We're basically concentrating the contaminants in the compressed air stream. So we need our air treatment, our filters and dryers and air receivers to help filter some of that out. Here's a pretty typical layout of what you should see, and pretty much kind of an order of how everything should be. So we start with the air compressor. It's sucking in all that ambient air that's just floating around out there with all the stuff that's in it that we can't see with the naked eye, and it's compressing it. So first we go through the first particulate filter. We're just getting rid of the big stuff. Dust, dander, organic material, stuff like that. Then we send it to a dryer, and that can be either refrigerated or a desiccant dryer, or there's some other specialty stuff out there. It could be any of that sort of stuff. It's going to reduce the amount of debris and stuff that's in the airstream even more. Post filters cleaning it up even more, and then even that dry air receivers cleaning it up even more. It's just allowed to cool down and stuff will start dropping out. And then once we do get out to the system through either the flow controller, so we are controlling the pressure in the shop, or we run it through a vapor filter. Activated carbon's pretty common. I used to sell a lot of these things to distilleries and breweries and places like that, pharmaceutical companies, because they wanted as absolute clean air as they possibly could get, did not want any hydrocarbons in there. But the one main thing, if you notice kind of at the bottom of that picture, is all the drains from all the pieces of equipment going into an oil water separator. So once we remove all this stuff out of the airstream, we want to be able to send it someplace to be treated before we just pour it down the drain. Oil water separators, and I'll kind of get into that a little bit here later in the presentation. But they do need to be maintained, and they basically absorb any hydrocarbons, any junk that may be coming through before we just pour it down the drain. This is more of just the components of the air system, and really what I wanted to achieve with this slide is the compressor is basically the first piece of the air treatment that we're going to do, because we have those aftercoolers in compressors. That aftercooler is going to start cooling the air down, get the moisture separator to work correctly before we start sending it down to the rest of the air treatment. We have coalescing filters, we have particulate filters, general purpose filters that will start removing more and more of the liquids, the aerosols, any debris that may be in their organic material. Send it to a wet receiver. Some systems have a wet receiver before it actually goes to a dryer, refrigerated or a desiccant dryer. That helps buffer air. If you have a reciprocating air compressor, because we bounce around so much, we may get surges within the system. So we want a wet air receiver to help with that. Dry air receiver, so we want to store dry, clean air for use. So when that application in the shop requires it, the dryer is ready to go. We're not pulling it through the dryer. Vapor removal, again, if we're dealing with something that's very sensitive to certain things, we want to make sure we remove all that. And then the oil water separators. Those are big parts of this system. So when we go to installation, where's the first place we should look? Pretty much every manual has some section or pages in it talking about how to start, what to do for the installation, how to do the startup, what piping is best application for that thing. And also not just for the air side, but also for the electrical side. What's the electrical requirements? How many BTUs is it going to generate? The dryer, if it's a refrigerator dryer, it's going to generate some heat. If it's a heated desiccant dryer, it's going to generate heat. How much BTUs is it going to generate? If it's a water-cooled refrigerated air dryer, how much water flow do we need? What temperature does the water need to be? All those kind of things. What fuse sizes does the disconnect need to be? So just make sure you're aware of all that. It's readily available from the OEMs and so forth. So just make sure that's a first point of reference that you go through when you're talking about installing stuff. And I'm just putting a quick punch in for this. Don't forget startup checklists. Technicians are great people, and they want to do a really good job at sometimes being rushed. They can forget to check something, do that tug test on all the wiring in the cabinet, making sure everything is tight, because that stuff can travel across the country. Things can loosen up. So we want to make sure everything is as tight as it possibly can be. And this is just a good reminder for that. Pretty much most of the manufacturers I'm aware of have something for a startup checklist. But step one is always, choosing what's the best location for air equipment, for the compressor, the drying equipment, the air treatment, the tanks, the reservoirs, all that sort of stuff. So we want to look at accessibility. Can we get our equipment in there? Do we have access to it? Do we have room around the equipment to navigate the equipment, to service it, to install it, to run the piping? So we always want to see about 3 feet all the way around pieces of equipment. I don't care if that's a compressor or even air treatment. We also want to make sure we put in a clean, dry, well ventilated area away from other contaminants. So if you're at I'm using an example of a cement plant, we don't want to put the compressed air equipment right in the most dustiest part of a cement plant. So just keep those kind of things in mind. Also, safety and security is a big one to keep in mind as well. Does it need to be locked down? Is it okay if people go in and start messing with it? And especially with like a heated desiccant dryer, those vessels get very hot. We don't want people touching them. So we want to make sure that we keep them safe, not giving themselves blisters or hurting themselves further in that. And security, just so people aren't walking by and poking at buttons. Maintenance requirements, can the guy have access to it? Do we have to send the skinny guy because we only have about a foot between the dryer and the wall? Those kind of things. Just, make sure we're doing those things. Keep away from additional heat, boilers, furnaces, direct sunlight, and those kind of places. Those are not good for compressors. They're not good for air treatment, and so on and so forth. Noise levels. Air treatment makes noise. When those EDVs go off, electronic drain valves go off, they can be startling. You don't want to set it next to an office where people are going to be working, or, next to someplace on the assembly line that could be, startling to people. Electrical requirements, think about, okay, where's the electrical coming from? I've sat in many a pre-construction meeting looking at blueprints with the plumbers and HVAC and all the whole people, and it's my turn to speak, and it's like, well, where's the air compressor going? Oh, we forgot about that. Can it go on the roof? Can it go outside? Me coming from cold country in Colorado, we don't stick anything outside. I know California, the Southwest, they'll put stuff outside all the time, but in colder climates, we can't quite do that. So just be mindful, figure out where that needs to go, because then now the electrician needs to know, hey, I need to bring 460 volt wiring over to this corner of the building. And the HVAC guy, oh, I need to provide heating and cooling over there and so forth. So just kind of keep that in mind. And also, are there drains for the condensate that we are pulling out of the air system? Does it have a place to go after it's going through the well water separator? One of my rules of thumb, and I wish I could remember who said this, I don't know, 15, 20 years ago to me, but put the air equipment where you would want to work. If it's pleasant for you, it's more than likely going to be good for the compressed air equipment, the compressor and the air treatment and whatnot. One of the most common mistakes I've run into is they don't give thoughtful thought where the equipment needs to go in a poorly ventilated area, cramped, dark, oily. I've seen equipment being put in a lot of different places. I always feel laying out the equipment is the first step, either on a piece of paper, actually physically putting the pieces, playing Tetris in that compressor room. So, and choosing the right piping to go between everything. The best options are, steel, either carbon, galvanized or stainless, copper and aluminum are usually the biggies. Use ductwork, and you can see in that picture, they're in the process of running the ductwork to vent those compressors outside. So use ductwork, and then they can also, in cold country like where I am from, we can then in the cooler months use some of that heat the compressor and the dryer could be generating and help supplement the heat to reduce the heating bill. And piping should be appropriate size for the flow and rated pressures that you're using. So just make sure whatever you do use, it's appropriate for that. But there is one word of caution. Do not use rigid PVC for airlines. It is not designed for compressed air. There's oils in compressed air that will start interacting with the PVC since it's a petroleum product. And I've seen I've never witnessed it shattering. I've seen the aftermath of piping shatter. Shrapnel, people get hurt. It's an OSHA violation. So just do not do that. One other thing that I've always felt is it's like one of those unsaid common knowledge. Everybody knows it, but nobody talks about it. Make the piping make sense. You can kind of see on the left-hand side, there's those installs. You can see where the piping goes. It's very easy to understand. Okay, this comes from the compressor, goes to the air treatment, goes to the tank, and it goes out. That picture on the right, that's 3 compressors piped into 2 tanks, and it took me about 20 minutes to figure out where all those pipes went. It doesn't make sense. There's a lot of 90s. The more 90s you have, the more pressure drop you get through a system. So we really want to minimize how many 90s we do. So putting some thought into how we need to run everything is really important. And that's where I think laying out the equipment, either on paper or in the room, is extremely important. So one of the most common questions we get is, my compressor is this size, my air treatment is this size, why aren't they all the same size for the same flows and pressures and whatnot? We've all been taught to keep the airlines as big as whatever the outgoing compressor is, or bigger. So if it's 1.5 inches coming out, we want to keep it a minimum of 1.5 inches going through everything. And then once we get out in the shop, we can upsize to 2 inch or 2.5 or 3, depending on how big the factory is or how far the air needs to go. But there's one exception to this, and that's air treatment. And why? So air treatment, and I'm going to speak about ZEKS specific here. Air treatment is based on the flow and pressure drop of the air through the filter and dryers. We need the air to flow through at a very specific rate in a very specific way to minimize pressure drop, but also allow the air when it's in filters and dryers to have enough time there for the dryer filter to do its job. So for example, and I want you to remember this example in this chart. For example, Rogers machinery, a KR or KRV 25100 generates about 117 CFM at 100 PSI. The discharge on that unit is 1.5 inches. But if we look, and it's on the very next slide, but if we look at the dryer, it's actually rated, it's only 1 inch. Going into the refrigerated dryer, it's 1 inch. Going in the desiccant dryer, it's 1 inch. And also the filters, it's all 1 inch. So why is that? We look at the chart that's on the right, and we look at the flow rate. So if we go down on the left side of that table, we go to 100 and we go over to 1 inch. It allows 150 CFM to flow through that. So when the dryer companies are building stuff, they're looking at flow rates. You know, it could be hooked up to a Rogers machinery compressor, or it could be hooked up to something else when it comes to air treatment. So there's a lot of things. It could also be hooked up to multiple pieces of equipment. So just kind of keep that in mind. It's all about the flow rates and what we call the dwell time within the filters and dryers, so you get maximum usage out of the equipment. Now, question comes up is, hey, you know, on the refrigerator dryer, the appropriate one for that KRV 25100 is, it would be a 125 HSK dryer, refrigerated dryer, which is 1 inch. Could we jump up to the 150? Absolutely, you could jump up to the 150. There's a couple things to keep in mind if you decide to do that. And that's on this one, the economics of it. As you jump up in size, just to make all the piping work, you may also be increasing additional costs that you don't necessarily need to do. So look at that. Sometimes when we move from one base model to another base model, the price could be pretty significant. You know, as like that, like on the previous screen, if we move from a 120 heatless desiccant dryer and we decide to go to the 160 CFM desiccant dryer, because it's 1.5 inch inlet outlet, we're doing two things. One, we're moving up the size, tanks are bigger, piping is bigger, all that sort of stuff. So there's more cost to that, but there's also more purge that's going to happen, because the purge is based on the size of the dryer, not the flow going through it. So instead of, you know, about 18 to 20 CFM of purge air, it might be 25, 26, 27 CFM of purge air, which means now to that KRV, you're only going to get like 95, 98 CFM coming out of it as it goes through the desiccant dryer. Hope I'm not going too fast here. And if you have questions, please ask them. The second part of it, because like I said, this is a twofold answer, factory standpoint. We can build filters, like I have a little one in my hand, and we can have heads and filter bowls that can handle 3 or 4 sizes. The elements may change inside based on the flow and pressure ratings. So just kind of keep that in mind, that we can get, you know, we only have to stock 1 head instead of stocking 3 or 4 or 5 heads for 4 or 5 different flows and sizes and so forth. So that's just kind of the other one to think about. There we go. So now that you've installed this beautiful compressed air system in the most absolute fantastic compressor air room, what comes next? You know, what do we do after the install? And this is one of my most favorite quotes. I have been known to say it for years, and I will continue to say it. If you don't schedule maintenance for your equipment, we'll schedule it for you. Would you rather be in control of it, or do you want your equipment just to decide when it's time to, I need attention? So with maintenance and diagnostics of this piece, you know, once you have that air treatment installed and the compressor and all that piping's ready to go, that relationship with the supplier is just beginning, or whoever's going to be servicing that equipment. It's just beginning. So moving forward, you want to work with your distributor, you want to work with your OEM, the original equipment manufacturer, technicians, to make sure we keep that equipment in tip-top shape and working and scheduled when it needs to go down for maintenance and service and so forth. So when providing good service on a machine, technicians should always remember several things. You know, we want qualified people on this thing. We don't want to just pull somebody off the street. If somebody's used to working on trash compactors, does that make them qualified to start working on compressed air equipment? I don't think so. I don't know. He may be very talented, but his knowledge is going to be in trash compaction or whatever. Always use personal protective gear, you know, glasses, gloves, arc flash equipment, whatever it may be. Always make sure you're wearing the proper PPE. for whatever you're doing. And always, always, always follow company-wide, local and state and federal regulations when working on equipment. Really applies more like when you're working on refrigeration equipment. You got refrigerant, you need to be licensed to handle that sort of stuff. Scheduled maintenance. Every manual that I have ever seen always has a section, a page or 2 or 3, that tells you exactly what you need to do. We're not hiding the fact of what needs to be done on this this piece of equipment on a daily, monthly, annually, semi-annually kind of basis. So refer to your manuals. They come with all the equipment. If you don't have it, go back to your distributor, go back to the original equipment manufacturer, and they'll be happy to supply all that stuff to you. But the answers are in the manuals for the most part. Two of the biggest questions from my 25 years of being in this industry I always get is, hey, I'm getting water downstream. Let's check the drains first. Do the easy things first. Just troubleshooting 101. Look at the obvious. Oh, that drain is stuck. This could be stuck open. I'm not getting enough pressure downstream. It's just blowing out. Or it's clogged up and it's just not blowing anything, which means it's letting water go downstream. Always check your drains, and those should be checked every day. Just a quick test. Most of them have a test button, either electronic drain valves, like what you see kind of pictured on that picture on the left, or the pneumatic no-loss drains. They have a test button somewhere, a switch to hit to check it, just to make sure everything is working. And then those 2 condensers on the right side, which one do you think is going to work better for doing what you need it to do? And it does also apply to the air-cooled aftercoolers on compressors. In Colorado, we get a lot of cottonwood trees at this time of year, and they plug up these coolers so fast. So just be aware of that. Parts of the air treatment that are often forgot about. They just kind of get put in and they just get spaced out for whatever reason. They're in dark caverns. They get stuck in the corner. Drains. Drains are all over the place. If you think back to that very first picture I showed you where it had like 7 drains, one for the compressor, the pre-filter, the dryer, the post-filter, the tank, and so on and so forth. There's a lot of drains on the system, and air treatment really isn't working unless you're really getting the moisture out of the air system. It's first line of defense. Make sure those drains are working. Filters, there's a lot of variety to pick from. There's little inline filters. There's big flange filters for larger systems. And then there's big mist eliminators. Mist eliminators are a very unique filter out there in the element last 10 years because it is so oversized. It's a filter on steroids. If you're concerned about pressure drop and energy costs, and because due to that pressure drop, mist eliminators are a great answer to that. Also, as a side benefit to a mist eliminator is if you're not going to maintain it, get a mist eliminator. It's good for 10 years. And obviously with the condensate, we want to make sure that we're properly treating the condensate before it goes down the drain. So, we want to maintain our fishies, and so they have a good life too. We don't want it to hit the rivers and oceans and lakes. The media inside oil water separators are usually 4,000 hours rated. I've walked into many a compressor room, and that oil water separator, because it has no moving parts, it just sits in the corner and doesn't do anything. People forget about it. It gets covered with stuff, tires and other equipment. And when was the last time that was serviced? Oh, I don't know. Well, when was it installed? Oh, my equipment was installed 3-4 years ago. Okay, it's probably time to get that thing serviced and make sure we're doing what we need to be doing before we just send untreated condensate down the drain. And because I didn't have a picture of a desiccant dryer and the layout of a desiccant dryer, I thought this was really good. This was right from one of the Rogers earlier webinars. So you got your oil-free air compressor, you got a wet receiver, that's that first tank, which is then going through a coalescing pre-filter, then to the desiccant dryer, and then out through a general purpose filter, and then into a wet tank, and then out to the system. And if they needed an activated carbon filter for whatever higher filtering, they can do that. One of the interesting things with refrigerated and also then with desiccant dryers is where the filters go, because they do have a very specific place to go. So on a refrigerated dryer coming out of the compressor, we want to put just a general purpose filter, get out the big stuff, get out the organic material, get out anything that may be in that airstream. It'll even work on liquid oil, liquid water, that sort of stuff. We send it through the refrigerated dryer, which pulls that dew point down, pulls out more moisture. And then we have that post filter. So we could put that post filter in front, but a post filter works better when the dew point's a little lower. It's more efficient. So it's pulling out more of any hydrocarbons and anything that may have kind of slipped through the refrigerated air dryer. But on a desiccant dryer, we do just the opposite. We put the high efficiency first because we don't want to contaminate the desiccant. So coming out of a compressor being an oil lubricated or an oil free for that matter, keep in mind that oil free is still ingesting air out of the atmosphere that you and I are breathing right now, which could have hydrocarbons, could have organic material, could have whatever. You could have hair and dust and skin cells and all that sort of stuff. First, we want to send it through a coalescing filter, an oil removing filter, because we want to protect the desiccant inside that desiccant dryer. As it's going through the desiccant dryer, the desiccant's actually moving inside that thing. So it's rubbing, it's turning into dust. So the after filter is catching that dust. That's its primary function. So on a refrigerated dryer, we have a general purpose dryer, coalescing filter. On a desiccant dryer, we do a coalescing desiccant dryer and then a particulate filter, a general purpose filter. Kind of weird. Now you can always double up the filters, both sides. You can put a general purpose high efficiency going into a desiccant and then general purpose and high efficiency going out. If you want to add the extra layer of filtration, you're more than welcome to do that. Just keep in mind, you do have some pressure drop that goes across the line. So out of that 100 PSI that's coming out of the compressor, going through drying equipment, going through filters, you may end up with 96, 95 PSI coming out on the other end of that thing.